Okay, so good morning, good afternoon for everyone. Thank you very much for joining us today within this webinar. You know, we are currently living on an exceptional situation due to this pandemic that we are facing around the world. So we want to appreciate your time and to join us. And secondly, we want to apologize in advance because, as you know, we are working from home and we are going to connect from Barcelona, Spain, and from New York. So in case any unexpected event might come up, we want to apologize in advance. So let's go for it. We have today, let me move to the following points of the agenda. We have a powerful agenda today. Well, my name is Laura Martinez, and I will start explaining you a little bit about nearly zero energy buildings, how they are here, and afterwards I will give the floor to a special guest that we have today with us, Diego Cuevas from ONYX Solar. Hi, Diego.
Hi, Laura. How are you?
Good. So he's going to explain us about PV glass and how to integrate it within buildings. And afterwards, we will explain you together with my colleague, Alfonso Mateos. Hello, Mateo. Hello, Alfonso.
Hi, Laura. Hi, Diego. And hi, everyone. Welcome to the webinar. I hope you will enjoy it.
Yeah, so we will explain you how our software in Dexma works, and we will display this new feature that we are releasing today, this app for microgrids, and then we perform a demo.
Sure.
Take into account also that we have a Q&A during the whole session. You can ask your questions and we will answer them by the end of the webinar. So as you can see on this slide, we know that the framework currently is that climate change is here and it's an emergency. There are several commitments like decreasing the global average temperature in the Earth or reduce the emissions that all of the countries around the world are facing and trying to fight against it. So in Europe, it's one of the most committed ones. So it's important to highlight this situation to understand where are we exactly. Then talking about buildings, specifically, we have to say that their contribution within this energy consumption and emissions is huge because they represent 40% of the total energy consumption in Europe, and they are responsible of 36% of the emissions. Besides this stock of buildings that we have, it's not so new. So we have 30% of buildings which are more than 50 years old, and most of them, 75%, are totally inefficient. So facing this situation, this framework, Europe is trying to put money on the table in order for these things to change. So there's a new budget for the next decade that is around trillion million euros. So to try to fight against this climate change and to reduce emissions by 2050. We have like you know, back in 2020, there were specific goals regarding three pillars, let's say. So we were talking about greenhouse gas emissions reduction that should be around 20%. This renewable share should increase around 20% also, and together with the energy efficiency. So this was the famous 2020 in this year. Yes, Alfonso?
These objectives were defined some years ago. Did we achieve these three objectives, Laura?
Well, we achieved some of them, like, for example, the emissions, in fact, in 2018, and we overcome this objective because it was at 23%. In others, like in the renewable share, we didn't. But in general, the global overview is positive. But now it's time to achieve this challenge of the next decade. So there are new objectives for 2030. As we can see, yes, we have doubled the greenhouse gas emissions reduction And also there's an objective of increase the renewables till 32% and the energy efficiency measures till 32.5%. In this last point is where we include the to increase the energy efficiency buildings of the buildings, and here is where the nearly zero energy buildings come into the equation.
Okay, Laura, I hope these new objectives are enough to fight the climate change, but could you please explain us what a nearly zero energy building is so that the audience can understand what this new word means?
Yes, so we are going to talk about it very often during the presentation, so it's important to explain and to define what a nearly zero energy building is exactly. So this represents a building that has ultra low needs. This means that most of the energy that it consumes comes from renewable sources that produce energy on site or nearby. So this is a building that is efficient not only on the way it behaves, but also on the way it has been planned, designed, constructed, and during, let's say, its whole life. So it's a concept that arranges a lot of topics, a lot of issues. And today we will talk more in detail about this integration of renewable sources, but it's important for you to know that it's a global concept for the whole life cycle of the building. There are sometimes some confusion about the terms, so we have to differentiate that nearly zero energy building, it's a building that meets its consumption with a huge amount of renewable energy. A net zero energy building meets exactly all their needs, so it's the orange line, it's the perfect building, let's say. And if we want to be more ambitious, we can talk about a positive energy building in which the production within renewable energies overcome the consumption needs. So it's important to clarify this. And then, well, this slide has a lot of text, but it's for you to know that the European Union has come with a plan. So back in 2018, defined that all the member states should move forward to facilitate the transformation of the existing buildings and new buildings into this nearly zero energy building concept. So each country should define which paths is going to take, defining objectives, and in order to assure that these guidelines transform into a renovation of the building stock. So Europe
Which are the differences between these countries, Laura?
Yeah, so let's go to a specific country's detail. For example, in France, they are quite ambitious, like I said before, so they move for a positive energy building, and they want in 2020 to all the new buildings become positive. So they have established limits about primary energy consumption, heating, and integrated renewable energy production. Within these 3 points, we can help with Dexma's EMS and the app that we will show afterwards. If we go for the UK, here they are quite ambitious also, and they expect to have net zero energy buildings by 2050 in all new and existing buildings. This is applied to both the operational and constructional energy. So we have the whole loop, like I said before. Here within our software also is important that we might help within these two parts of the whole life cycle, the operational energy use and the renewable energy supply. And with Italy as an example, here we have that all new buildings from 2021 that could have a renovation must be nearly zero energy buildings. So it's less, let's say, than in France and in UK, but also important. And it's similar to what we have in Spain. We will explain afterwards in the Spanish webinar. And here we have again this renewable share that we have to achieve, and Dexma might help with it. And just as a curiosity, 2 years ago, Italy had 1,400 nearest energy buildings. So there are still a few steps to achieve the objectives. Okay, so just to wrap up, as I was saying, nearest energy buildings are fundamental first on the way they don't lose energy. To do so, there are different ways, like improvements in insulation, passive design, or the way the buildings are built, like bioclimatic architecture. Then we have the system's efficiency, like using efficient appliances, increase the automation of the systems, and use common generation, like district heating or district cooling. And finally, we do have the sustainable energy production. And here is where the regeneration of energy comes within the storage. And I think here
ONYX has a huge experience to share with us, I think.
Yes, so I think that Diego might be able to explain it here more details about how to integrate energy on these buildings, energy generation. So Diego, I will give you the floor.
Thank you so much, Laura. It's a
you be able to control everything now. Please, can you explain us how you deal with these energy neutral buildings?
Sure, of course. Thank you so much for the introduction. So I'm going to be talking about PV glass for buildings. So actually, it relates a lot to what you've been explaining. I'm trying to pass the slides, but I don't know. I don't have the control. Sorry.
Yeah. Maybe now.
Yes, it looks like now it's working. Let's see.
Yeah, you have now. Okay. Sorry, these are the problems that we were at the beginning saying.
Good. So let's start over here. So, well, again, thank you so much for the introduction, Laura. So I would like to focus on the photovoltaic glass for buildings. So this relates a lot to what you've been discussing. So trying to make buildings more resilient, energy efficient, and well, to create renewable energy on site in such a way that we can have a great portion of the energy consumed by the building generated by new technology that it's going to help you in so many different ways that I would like to explain here. For those of you who don't know ONYX, we are a company headquartered in Avila near Madrid. We've been in business since 2009. We remain a privately held company, and we manufacture PV glass for buildings. So we use two main technologies, amorphous silicon solar cells and crystalline silicon solar cells, and you're going to learn the difference between them. And well, we have a fabrication plant that allows for us to manufacture anything from 1 million up to 2.5 million square feet a year of glass. And that's going to depend basically on the makeup of the glass, the dimensions. So each glass has its own receipt. So depending on the, well, dimensions, thickness, etc., we can manufacture anything from that range, the lower range to the larger range, okay? So we have completed over 250 projects worldwide. And well, I would like to show you what PV glass is not, right? So if you see this image on the left, we have a situation where the architect may have run out of space in the roof. And well, to achieve a net zero energy goal, you have different ways to do it, right? Because personally, I believe that the image on the left, which is not BIPV, I would like to emphasize that, it looks like a kind of a spaceship made of PV panels landing on the roof, and that compromised the architecture a lot. So the way we would see this project, it would be analyzing the complete envelope of the building and trying to understand different parts of the architecture from where we can generate electricity, okay? Because it's a building that is going to be receiving a lot of sunlight. So we have opportunities on the skylights, on curtain walls, on railings, on canopies, etc., right? So that's a different approach, and we should see the building as an energy source, as a power plant, actually, so we can try to generate electricity from different areas, such as the one or such as the type of application that we see on the right, which is a canopy integrated as a building material, actually. So a really simple concept of what PV glass is, right? So it's an architectural glass. So first of all, and I would like to emphasize this is a building material. So if you go with PV glass, you don't have to buy a conventional material that you will have to install otherwise. Okay, so this is going to enclose your building, this is going to insulate your building, and at the same time it's going to provide you clean electricity from the sun for the next 35 years, which is great. So the main properties of PV glass, first hand, we have the energy generation, of course. So we are going to help you decreasing operations and maintenance costs for your building. We filter 99% of the UV radiation and up to 95% of the infrared radiation. Also, it offers you thermal and sound insulation, so we can go as low as 0.13 BTUs and provide you a superior performance. So for example, for airport projects where you need good sound control, the PV glass, because of its composition with the different glass plies, is going to give you a superior performance from an acoustic insulation standpoint. So it offers you also natural illumination, so we can meet where your design goals. So we can offer you glass that, besides providing you electricity, it's going to generate it's going to give you natural light. So it's going to help you decreasing artificial lighting needs inside the building. And obviously it offers innovation in design because this doesn't look like a conventional PV panel. So here we have a picture of both technologies. On the left, we have the amorphous silicon solar cells. On the right, we have the crystalline silicon solar cells. Really briefly, just to give you an overview, amorphous silicon glass, it's a coating, okay? This is like a spatter coating process that we apply on a layer of 1/8 inch thick glass. So really flat, thin glass, okay? And it's like adding solar cells through spatting process. And this is going to allow for us to create a glass that, well, it can offer you different light transmission levels. So we go from dark, fully opaque glass that you traditionally use, for example, for an spandrel situation in between floor and floor. And then we can go for 10, 20, and 30% light transmission levels. That's a typical glass that you're going to be using, for example, for a courting wall application, for a skylight. So whenever you want day lighting inside your building, you're going to go with a semi-transparent option. Here, the thing is that there's a trade-off. The more transparent you go, the less energy the system will generate. So we have to assess together with you what's going to be the best balance between the energy generation and day lighting needs for your building. So the efficiency ranges from 3 to 5% on average. The good thing about this technology, as you can see in the image, is that it generates out of diffuse light conditions. So if you have a cloudy day or shadows projected, or your building is located in London or even in Edmonton, this technology is going to keep generating power, which makes it really interesting for 13 locations worldwide. And it offers you also a low temperature coefficient, so you can work, well, in a huge range of temperature options. So it performs from -45 Celsius up to +85 degrees Celsius. So it's really unique. Then we have the crystalline silicon technology. So here we work with the standard conventional crystalline silicon solar cells. However, we play with them a little bit, right, to provide the passive properties that the PV glass requires. So we are going to have 6-inch solar cells, sorry. And the efficiency at module level, it's going to go from 10 to 17%. And basically, we are going to spread them out if you want to put day lighting inside the building. And we're going to put all them together if you want to generate more power. This technology is more powerful compared to amorphous silicon under direct sunlight. However, if you have a cloudy day or shadows projected, this technology will drop production almost to zero. So that's why we need to assess the architecture of the building, the location, the tilt, the orientation, etc., to assess and provide you the best guidance possible to make this installation work in an optimized manner for you. So we can do colors, we can do shapes, we can do, well, customized designs. We like to be the ones that adapt to the architectural design. So we are here to help you. ONYX is a resource tool for the architects because we don't want to disrupt your design. So basically, you're going to tell us what type of glass you need, the dimensions of the glass, the thermal performance of the glass, the color, the thickness, the composition, etc. And we're going to create something, that it's going to meet your specification for your project like that. And we can manufacture actually glass units up to 13 feet by 6.5 feet on average. So it's really large glass. So I would like to show you some applications of what we've been doing, okay? And this is the best way to understand the technology. So here we have, for example, on the background, we have an image of a PV skylight made with crystalline silicon solar cells. As you can see, we can monitor in real time the performance of the installation. So in this case, this is great because Dexma is going to be able to monitor the production of this type of equipment. And as you can see, from year 1 to year 5, we've been overperforming compared to the expected by the utility. And this is a project in New Jersey, and it's been up and running for almost 8 years or 10 years now and working really well. The good thing is that we can monitor things and ensure that they are working properly as per the specification. We have, for example, a PV skylight here. Also, this is in New Jersey as well, in Homedale. This is home to Bell Works, a former Bell Labs building, and it's a really unique installation, a 60,000 square feet of glass. When we originally met the owners, this skylight was leaking everywhere. It was in desperate need for a renovation, and we ended up doing or installing the PV glass with a morphosilicon solar cells, which allowed for the light to receive a lot of sunlight, a lot of natural light, decrease the artificial lighting, but at the same time generate a really good amount of power. So that translates into a beautiful final result, as you can see here. So it blends really nicely with the rest of the architecture of the building. And well, imagine this. This is a building of a 2 million square feet space, right? So the energy consumption for this building is huge. So with this installation at the skylight, the owners of the building, they are offsetting a 15% of the energy demand of the building, which is going to be a lot of money. We have also applications on the vertical plane. So this is a ventilated facade for Pfizer, the pharmaceutical company, actually in Granada in Spain. So who would tell you that this is a PV glass, right? A PV product that generates electricity. This has nothing to do aesthetically compared to a conventional PV panel. So that's a great aspect of the technology, right? The architecture aspect of the technology. We have second skin facades as well. This black color glass, it blends really nicely also with the design of this building in Bursagat for Turkey, in Turkey, the gas supplier for Turkey. And in this case, this is made with a morphosilicon glass as well. We have PV fins as well. So these vertical elements, they provide you shading to your building. So they control really well solar heat gain coefficient, but at the same time, they generate electricity. So this is the University of Washington, the life science building, which is actually a benchmark project for other universities to follow worldwide, actually. This is a PV canopy made with crystalline silicon solar cells. This is a American Airlines Arena, home of the Miami Heat. I'm gonna run a little bit more because we are well, running out of time. This image shows you how flexible we are in terms of designs, okay? So in this case, we can do so many different color options, aesthetics, etc. We have transparent PV canopies. We have curtain walls, facades with crystalline silicon solar cells, Balenciaga in Miami. We have transparent curtain walls with a morphosilicon glass. This is Seneca College in Toronto. And this is a really unique application. This is patented by ONYX. This is a PV floor, which actually you can walk on top of it. It's anti-slip. So this makes the most out of every single square feet of your building because you can still enjoy your space on the roof, enjoy and hang out with your friends. And at the same time, you're complying with the code and generating electricity for your building, which is great, actually. So here we have an outline of the economics and the environmental benefits of these installations. And just to wrap up really quickly, we do assessments for your buildings, right? So if you share with us the project drawings for your building, we can calculate for you how much power your system is going to generate, well, what's going to be the return on the investment, the payback time, the increase on the building value, but at the same time, we're going to show you the electricity generated by the building, the CO2 not released to the atmosphere, etc. So we are going to help you understanding your options for renewable energies on site. And this is another study that we can do for skylights as well. So we can do it for any application in your building. And the good thing about this is control, right? Because you need to measure the results of your investment. So for this purpose, we have Dexma actually. So Dexma has a great software and they are gonna keep talking about it because you can monitor from your computer on real time the performance of your equipment, which is great to make sure that you don't have any deviation from the expected performance of the system. So I would like to pass it or or have Dexma talk about their system more. I'm sorry because I extended myself a little bit more than what it was allowed.
Thank you,
But thank you so much.
really,
We'll
really,
address any questions at the end.
really
Yes.
amazing ways to include the PV panels in a building, even in the floor. It's really interesting ways to make your buildings nearly zero energy buildings. So thank you very much.
My pleasure.
Yes, thank you very much for your explanation. Then let's move forward on the presentation. Yeah. Yes. So let's explain now a little bit about us, about Dexma. So we want to briefly wrap up our mission, and our mission is to help people and organizations understand and optimize their energy use. To do so, we have been developing software, energy management software, for the last 10 years. And we believe that the future, we really, really believe it, it's digital, and we are building it building per building, step by step. So our database has currently tens of thousands of buildings, and we are helping them to save energy and become more efficient. This is our mission. To do so, we have a unique platform, and we consider it as a unique platform in the market due to these three reasons. So through the energy efficiency journey, we have developed 3 modules to help our customers. First, to detect savings potential without performing outside audits, using our database, and within artificial intelligence, give them recommendations. Then we have the analyze module, where we verify savings using real-time data. And then we have optimize, where we can discover anomalies and save time to our customers. But I think it's better if Alfonso, as product owner, explains more in detail about the product and the new feature. So Alfonso, feel free.
Okay, thank you, Laura. As Laura said, we think we have a unique platform that goes from detecting the potential, then analyze, and finally optimize. This first step of this energy journey is maybe you don't have hardware in your buildings, or even you don't want to invest on it, but you always do have other information, like maybe some smart meters, energy bills, and of course you can provide us with a lot of metadata, like the location, the activity, the surface of your location, so etc. With all this information, we can compare all your buildings with our 80,000 already monitored buildings in our database. And that's really important, because then we can apply big data and artificial intelligence algorithms to deliver portfolio benchmarking, to compare between all your buildings, virtual disaggregation, so that you can know which part of the consumption relates to age, for instance, and then also recommend you retrofits in each of your buildings. It's like, let's say, a virtual energy audit, but massive for all your locations, and that allows you to detect where to focus, where you should focus, in which locations you should focus to save the most energy. So this is the first part of this energy journey. Then the analyze, the second step, when you know where to invest, you do install some hardware, some submetering meters, and then real-time monitoring comes to place. Analyze and verify the savings is the idea behind the analyze module of Dexma platform, like the M&B feature, where you can verify in real time how you are performing in your EPC contract or in any retrofit that you may install in your buildings. And also, analyze allows you to look in detail your whole building energy balance, as we will see today. And also helps you to optimize as a team. It allows you to share reports, alerts, analysis with your partners or with your customers, and helping you to verify how your projects are performing in detail. Okay, so first we detect, then we can analyze these savings, and the third step is to optimize. In Dexma, we've realized during a lot of years that the most data you have, the lower you can analyze it. And it's normal because there is not enough time and maybe not enough people to analyze the huge amount of data that you are sending to Dexma. So you have to work with tools like Dexma Optimize that uses artificial intelligence to analyze automatically, continuously your data, and being proactive, showing the inefficiencies, anomalies that a machine that works 24/7, it doesn't stop, is able to automatically detect. So the idea here is that we are providing you the technology, the artificial intelligence, right, to detect and to analyze and to focus on what really matters of your buildings. Okay. And well, now we will share with you a new feature that is called the Microgrid app. It's a feature especially focused on nearly zero energy buildings, but also in renewable production. This Microgrid app allows you to track your nearly zero energy building key indicators, the energy balance between on-site generation and the storage, and the energy consumption of your building. It allows you to check the environmental footprint and reporting the cost savings related to renewable energy production. And the most important, that everything is in the same platform. Our unique Dexma platform allows you to do all this work in the same place. This feature will be available in the following weeks, and you can start contacting our sales team for price options and so on. But now I want to show you a bit how this app looks like, and then a demo in real time that I will share with you. The first, or the main screen of the Microgrid app is the energy balance screen. This screen shows the energy that goes inside and outside the microgrid, like grid import-export, generation, the storage, or the loads or consumption of your building. We will see it in detail, so I will pass the slides. The renewable production, or this is in detail what the generation performance is, performance analysis, performance ratio, radiation, let's say PV module temperature, and so on. The same for the storage. We'll also have the possibility to check how our storage, our battery system is performing, its temperature, its charging and discharging cycles, and so on. Or even analyze the whole energy flow in the building through a Sankey chart, a Sankey diagram. Why? To have data-driven decisions. Do I really need to increase my solar plant, or it is enough? Let's say maybe a bigger battery could help also, and so on. We will take a look on the settings. As you can see, the app is focused on how the building, the microgrid of the building is connected to the different parts, like the grid to import and export energy, to the generation. It could be solar plants, but in the future, why not wind power, and so on. Storage, that is not as common as renewable energy, but it's becoming more usual in the buildings, and also the consumption of the loads. Okay. And the last slide I want to share with you before the demo is the report. All this information on the platform could be seen in a report that is showing the cost that you avoid because of generating energy, and so decreasing the energy you have to buy, basically. So it's also providing you information on the cost you are saving and the environmental footprint even. Okay, so I think let's go to the demo. So I want to show you the feature, the microgrid app.
So Alfonso, one question at a time.
Yep.
Yeah, I was asking because, as you know, most of the renewable energy buildings do have a battery, but do you think that most of the installations only have a solar PV panel and do not perform storage? How do you deal with that?
Well, in fact, our microgrid app takes all the cases into account. So we will now see how we can manage both the generation and the storage. So let's start. We'll select location. Here you can see the energy balance of the previous year, but well, just to get in more detail, we'll focus on, let's say 2 weeks. So, and in an hourly resolution, here you can see something that I'm sure that begins to be familiar, but let me start with another location, then you will see why. Let's start with this location, this building. First of all, I want you to focus on this axis on the left, the energy balance axis. Okay, on the positive part of this axis, we have the energy sources or the energy that is going into the microgrid, and on the negative part, we have the demand. So as energy that goes into the microgrid, we have, let's say, the grid import or the generation that is provided to the microgrid. And then on the negative part, the energy that goes outside of the microgrid, like the consumption of the loads or the energy you may export to the grid. But let me disable this for the moment, but the consumption, to explain you how the cycle goes. This is the consumption of a building, okay? We see in opposite because it's energy that is going outside of the microgrid, and we are representing this on the negative part. Okay, so how to cover this consumption? We can, of course, place a generation. As you can see, this generation is about 76 kilowatt of power. It's a good generation, but it is not enough to cover the whole consumption during the working days. But in fact, during the weekend, there is some exceeding energy. So we can expect that this energy is being exported to the grid. And here you can see which is the amount of energy that the building is exporting to the grid, is selling to the grid. And to cover the rest of the consumption where the solar plant is not available, there is no sun during nights and so on, we also have the need of importing some energy because of two reasons: because the solar plant is not always available, and also because it is not enough in this case to cover the whole consumption. Maybe a bigger solar plant could cover more part, or also other efficiency retrofits that can lower that consumption. Okay, so this is how the energy balance screen manages all this. You can also see it in detail in the table, the energy sources that are grouped in top and the energy demands total. So all this data is available for you to analyze. You can even see it in lines so that you can better compare between the magnitudes of each of these concepts, or you can analyze also in a Sankey diagram to see the flow. You can see how the load consumption is covered partly from the production of the renewable energy. The point here is that we are talking about the nearly zero energy buildings, and these, what we've seen so far, is what most solar plants look like in a building. So that's why I want to show you now this same location, but with the simulation of a battery inside. If we have a battery, then part of this exported energy to the grid will go inside the battery, will charge this battery. And then when the solar plant is not producing, where there is no sun, the discharge of the battery will provide enough to cover the night consumption, and therefore not having the need to buy energy from the grid. If you see, without the battery, we are consuming 81% of the energy we produce, because a lot of the energy is sold to the grid. But with the battery, we are consuming up to 93% of the energy we produce. So it's a good way to optimize the production of the building. So, but Microgrid app also allows you to analyze other parts of your facility, the performance of your solar plant. As you can see, the performance ratio, the production, the irradiation, even the module, the PV module temperature, and so on. And you can, of course, see the data in our table. So to get a deeper analysis of the performance of your solar plant, and the same for the storage. So you can take a look on the state of charge, battery temperature, and charge or discharge cycles also. Okay, so basically this is what the app can do for you, but I want you to understand one thing, that is, I will show you now the settings, that this app is not only showing you what a single solar plant can do, but we can add more than one solar plant, or more than one battery system, or even more than one grid. If you have, for instance, 2 grids in a hospital for redundant needs, etc. So you can start adding as much systems you have to get that information and that energy to the microgrid. Okay. And the last part I want to share with you is about the cost and how to report all this information. So as we said before, we have this this avoided cost report, let's say, and where you can define which buildings you want to analyze, for instance, the solar plant with battery, or you can, of course, select your logo. You can define the coefficient of the CO2 emissions, or even the increase concept, and several trigger options to get this report arrive to your partners and customers. And in the report, as you can see, you have an overview of the costs and consumption of your installation. It shows the avoided cost due to the renewable energy produced, has an overview of the energy flow and the energy bought and sold to the grid, and also it tracks the emissions that are avoided thanks to the renewable production, or the evolution of consumption, and so on. So we think that we have really interesting options to analyze the performance of your renewable energy and your nearly zero energy building. But that's not all that we want to deliver. So coming soon, we will have this production dashboard. It's like a portfolio analysis dashboard where you can track the performance of all your solar plants and nearly zero energy buildings. You can compare all of them. You can take care of those plants that are performing not as good or are not working at all, to have that overview that helps you to focus on the important things. Okay. This will come next to the production baselines, that comparison. This screen is thought to compare the real production that you are getting from your solar plant, let's say, with the budget or the evolution of the production among years, or compare it with the expected production when the solar plant was projected, and also enabling you to export all this data and to have your own analysis, let's say in XLS files. So how to track this evolution, let's say. And in the data sources part, you can, as always, see all the data sources that we have integrated. Hardware agnostic. You know that Dexma likes to integrate as much hardware solutions into your platform, and in solar purposes, we are integrating 2 of the key manufacturers in terms of inverters. They have a huge presence in the market, and these 2 inverters are the Huawei through their platform, the Fusion Solar platform from Huawei, and also the Enlighten platform from Enphase. So these 2 inverters will are being integrated into the Dexma platform, so that you can get all your data inside the platform and start analyzing it. So, well, in fact, that's it. Maybe a recap of all the things we have talked about, Laura. Lots of things we have showed today.
Yeah, in fact, yeah, thank you very much for the explanation, Alfonso. Just to wrap up within this slide, we want to show you what we have talked about in this webinar. We have explained you a little bit about the near-listed energy buildings regulation in Europe and in specific countries. Then we have learned with Diego how PV glass could produce energy within the buildings. And then Alfonso has showed us this Microgrid app, this new feature that we have in Dexma, where we can have the production and the consumption within the same platform, Dexma's platform. It's easy and quite visual to configure it, and then we can track our impact from environmental and economical perspective within the reports. So these are the key points that we have been talking about. And yeah, so I think our next slide, that's it. Now it's time for Q&A. So thank you very much, everyone. And let's check these questions. We are very happy to answer them. So I think, let me check.
They're asking when this feature will be delivered. It will be delivered during the next weeks. So it is not available right now in the market, but we will be prompt as soon as it is available there. So you will be able to install it and start enjoying this amazing app. We are proud to show to you.
Okay, well, I see also a question for ONYX, Diego. A person has asked, which type of inverter should we use for your Phonos and Crystal PV glass?
Sure, definitely. So we work with conventional inverters. So especially for crystalline silicon glass, we can work with renewed brands such as Fronius, SMA. So they are going to be central or string inverters. Also, right now, well, there's new regulations for the rapid shutdown, especially in the States in particular. And in this case, we may want to use micro inverters as well from Enphase, for example. So there's many options, right? But I would like to highlight the fact that we don't need a special inverter. So the electrical portion of the technology is going to work the same way as a conventional PV panel. So that's really good to know, because you can use any commercial inverter that you can easily find from any distributor.
Okay, so thank you. And I see also one more question, Alfonso, maybe you can ask this one. They are asking what all hardware is required to gather the data from a particular location from the app.
Okay. Well, it depends on what you want to achieve, but basically the energy measured. So you have to measure let's say the grid, import and export, and this should be or usually is achieved by the facility smart meter, and you have to measure the production of energy and if available, the charge and discharge from the battery, and if not, the consumption of the building. So with this, you will have all the amount of data that you need for the energy balance. And then, of course, if you want to go deeper in the analysis, you can provide us the radiation that you can also get virtually from Dexma. But if you have a physical proof, you can also provide it, temperature of the devices, and state of charge and of the battery, and so on.
Okay, so thank you very much. Yeah. Yes, I see that we have more questions, but we don't have more time. So we will answer them by mail. So yeah, thank you very much, everyone, for joining us today. Thank you, Alfonso. Thank you, Diego.
Thank you so much for the opportunity.
Yeah, thank you. Thank you, Diego. It was really, really interesting. And thank you for you, Laura, and for you guys to attending this this webinar. So see you in the next Dexma webinar.
Yes. Bye bye.
Thank you. Bye bye.
Bye.